Okay, welcome back. In this portion of the module, talk about the vertical structure of the atmosphere. Um, Throughout this module, you'll see some definitions. Um, you'll need to go ahead and learn those. But in a nutshell, the atmosphere, because most of it resides close to the surface due to gravity pressing down on the atmosphere, as you go up in the atmosphere, so up in the troposphere where we are, and then up into the uh, further reaches of the atmosphere, something called density and then something called pressure both drop off very quickly. Now, the definition of density is the mass of a substance in a given space. So the substance is the atmosphere. Okay, the atmosphere can be compressed. So if you consider a vertical column of the atmosphere, um, the air in this column has some kind of mass. Okay, the weight compresses the air at the bottom of the column, and that compressed air is a higher density than the air above it, and that is due to what I talked about before, which is gravity. Now, pressure, very similar to density, is a force exerted by a substance over a given area. Or, in a nutshell, it is the weight of the atmosphere above you. Now, I took this from my MTR 1400 course, some of these slides, so don't worry too much about this piece of it, just the definition of pressure and the fact that pressure drops off very quickly as you go up into the atmosphere. In fact, this image here is very interesting. You can see here, and I talked about it before, 99% of the atmosphere resides at about 19 miles or 31 kilometers or below. About 90% is here at about 9 miles, and then half of our atmosphere is actually about, I don't know, 3 to 4 miles or so. So it compresses very rapidly. Hence, pressure dropping off. And we know, at least a lot of us know, that have hiked 14ers and things like that, that as you go up to those reaches, that air density does drop off, and it's harder for us to breathe. Layers of the atmosphere. So this is important too. We can divide in atmospheric and climate science. We can divide layers of atmosphere up by different properties: temperature, chemical composition, electrical properties. In the climate and weather world, we divide it up by temperature. Okay, so we only define layers that are changing in temperature. We measure it with a weather balloon. Don't worry too much about the technical term for it. So this is an image of the layers of the atmosphere. So where we live is called the troposphere. The layer above it is the stratosphere. Mesosphere above that, thermosphere above that. Okay, so we're interested in the troposphere and the stratosphere, for example. And really what I want you to know is particularly what are the order of these. I won't hit you too hard on the actual elevations or altitudes that these actually change. But you can see here, this is the temperature profile of the different layers. So in the troposphere, the temperature drops off very quickly. Then when you hit the stratosphere, it actually increases. When you hit the mesosphere, then it decreases again. And then when you hit the thermosphere, it quickly heats back up. So very typical atmospheric profile, and these are the 4 layers of the atmosphere. Stratosphere somewhere in the 11 to 50 kilometer range. Here's some more definitions. I don't think you need to worry too much about them, actually. Just know that temperature increases in the stratosphere. And tropopause, there's pauses in between each of these layers that I won't test you on. I just want you to know the basics as far as what the layers are, and maybe how deep the troposphere is and how deep the stratosphere is. The 2 top layers, mesosphere, basically is for middle atmosphere. Don't worry too much about it. Thermosphere is the hot layer. Just know that they are above the stratosphere with the mesosphere being below the thermosphere. Temperature scales, very basic. We know about these, hopefully from basic science in high school. Fahrenheit, Celsius, Kelvin. I'm not going to make you do any kind of temperature conversions. That's for my 1400 class. Just know these terms. There's 3 of them. And anyway, I always like to look at this where it's, just interesting what different types of things are going on as far as temperature goes. Like I said, this is a crash course in atmospheric science, so we're not going to spend a huge amount of time on it, but it's important. Okay, one of the things that's really important in our atmosphere, and we'll talk about it a lot in this course, is water. Water is really the only substance that changes phase in our atmosphere. So at any given moment, you're going to be surrounded by water vapor. Now, it may be a dry day where there's less water vapor, or it may be a humid day where there's more, but you can't see it. It is microscopic. It's actually water vapor molecules floating around. The more that are floating around, the more humid it is. Now, we can have situations where you take heat away from this phase and you end up condensing it. Okay, so it goes through condensation. Or take more heat, like this morning it snowed and it freezes. Okay, or you can add heat to the situation and you can change the phase of water. So when you change phase between these different phases of water, you're either taking or giving heat back to the environment, which is really interesting when we're talking about weather, and it's really interesting when we're talking about climate. The reason that it's so interesting for climate is it should be fairly intuitive that if you heat up the planet in an excess sort of way, so if you add more heat, you're likely going to change the phase of water. So you're likely going to evaporate more water. Or if you have areas where you take heat away, maybe it's going to cool for a certain reason, you're actually going to have less evaporation. Okay? So more is particularly interesting because water vapor is a greenhouse gas. So one of the fundamental things we talk about in this course is if you add carbon dioxide to the atmosphere, the temperature of the Earth's surface will likely go up. If the Earth's surface likely goes up, you likely get more of this. So you get this double-barreled effect. We'll talk about it a fair amount in this course. Heat transfer in the atmosphere. There's three different ways we transfer heat in the atmosphere. It's conduction, convection, and radiation. Okay, conduction specifically is transferring heat between substances that are touching. That's all you need to know for this. Okay, so we actually heat up the atmosphere through conduction. Okay, sun comes up. Actually, we heat it up with all 3 methods. Sun comes up, radiation gets a pretty good sun angle, radiation hits the Earth's surface, it starts to heat up, and then the layer of the atmosphere that's really close to the surface will start to warm through this process, conduction. Convection also occurs once you start heating the surface up and you get these bubbles of air. We call them thermals. Maybe there's a pilot or 2 that are in this class, or aviation major. You know what these are about. In the afternoons we get these thermals, and a lot of times we get clouds that form from these. So it's also another interesting kind of feedback from heating the surface of the Earth. You actually get evaporation, you get convection, those types of things happen, and you get cloud development. So clouds are another thing that we're going to talk about throughout the semester, being a main driver of what happens to our Earth's surface as far as temperature goes, and what are the ramifications of different branches of climate change towards clouds, because clouds are actually really good at helping us deal with heat on our planet. I'm going to skip through this one. I don't think you need to. I talked about it a little bit, but I think it's okay not to talk about it now. The last method of heat transfer is radiation. So radiation are electromagnetic waves. We specifically get radiation from the sun. A lot of this is left over from my 1400 class. Don't worry too much about it. Just know that radiation is a form of heat transfer. And this portion here looks like the exact same slide. Sorry about that. That's super weird. Anyway, here's some points to remember. So these bullet points would be interesting. Okay, all objects emit radiation. So even us sitting here, I'm emitting some wavelength, or you're emitting some wavelength of radiation, specifically visible and infrared. The sun actually emits ultraviolet and some other, and also visible and infrared, but mainly ultraviolet. The Earth, once it heats up, actually emits infrared radiation, and then we do as well. Objects emit radiation over a range of wavelengths depending on the temperature. Okay, so if you're cold, you're going to emit different wavelengths of radiation than if you're warm. As object temperatures increase, it emits radiation at shorter wavelengths. Okay, as object temperature increases, it emits more radiation. And the sun is a shortwave radiation because of this piece, and the Earth is more of a long wave radiation. And that's going to conclude this section. Sorry there was some extra pieces in there from my 1400 class, but I think it's okay if you go over and study that kind of material too, but hopefully I've pointed out the information that you need to know.